So before I begin, let me start this way. There was an engineer, a psychiatrist, and a physicist. And they were called in to evaluate a problem at a dairy farm. Production was far below the norm. And they each took a few days to evaluate the farm. They looked at the barns and the cows and the production equipment and the facilities and the fields and so forth. And after a few days, they each came in to make their assessment and recommendations to the farmer. And the engineer went first, and the engineer described all these technical details about, if you made your pens for the cows smaller, animal rights activists might not like that so much, but they described, you could fit more cows into the barn. If you made the diameter of the milk lines wider, the flow rate would increase. And this led to some amount of predicted production increase. They said, okay, fine, great, thank you very much. And so the psychiatrist then came in next and kind of took a different track and suggested, inside the barn, if you paint the walls green, it's a very soothing, warm color, and this will relax the cows and make them, more prone to produce greater quantities of milk. Outside, plant more trees where they have more shade to relax. This too would lead to them producing more milk. And so the farmer said, thank you very much. And the last to give their presentation was the physicist, who came in and asked for a big chalkboard. And he started writing some formulas in the corner and drew a big circle on the chalkboard and said, now imagine the cow as a sphere. Now, that's not a particularly funny joke, but it does illustrate something that I think that we're trying to capture here in this talk. This research talk is we're trying to evaluate a system with imperfect knowledge, so we're making some estimates. And we're taking a snapshot or a view of the world that may be imperfect, but if we can create a view that's reasonably predictive, maybe within an order of magnitude, say, then we can probably see something interesting, even if there's some reasonable error rate. We can see something that's insightful and maybe can lead us to some interesting results. So that's what we're actually attempting to do here. It's not necessarily a perfect view of the world of what we have to work with, but a view that I think hopefully we can lead to some insights. So this I may not have to tell many of you, or to convince many of you of this fact, but it should be understood that DNS, the domain name system, without any of the technology from DNSSEC, just the kind of legacy DNS that we've all known and loved, works reasonably well, at least from a user perspective, even in the face of many misconfiguration problems and server failures or unavailability. Things tend to get resolved maybe surprisingly well in many cases. And you could probably, many of you have probably thought of some examples where this is the case from all the lane delegations and those sorts of situations. But once we add DNSSEC to the picture, then things come much more rigid. And if you make one little mistake, that can lead to the whole zone being completely unavailable for anyone that at least is doing validation. And so this at least suggests, if you want to do DNSSEC, that authenticity really does require us to do that operational job better, where we weren't necessarily paying maybe as much attention to or worrying about in the past. So this maybe does, at least if not for real, it does at least present us some problems in availability. And it's certainly been suggested, DNS with DNSSEC is more prone to these problems, and we see them much more easily when we're doing validation. And part of the history of DNSSEC too has been quite interesting. For those of you who maybe weren't around in the days or who haven't been around since when the DNSSEC root was signed, there was a time just a couple of years before when no one thought the root was going to be signed. In fact, I asked one of the RFC authors of the DNSSEC specs, I said, is the root ever going to be signed? And without hesitation, they said no. And then Dan Kaminsky came along and produced this vulnerability that the world really reacted to in a significant way. There was a lot of momentum. A lot of people were very, you could say, maybe excited or motivated to deploy DNSSEC. And so within a couple of years, the root was signed. A bunch of TLDs were signed. The big validators now do validation, like the Googles and the Cloudflares and those sorts of things. And so there's a fairly significant amount of deployment that actually took place. Now, you can quibble with the numbers, but there's some things, some big pieces that are still missing. Many of the largest well-known names, like from the Cloudflare Radar Top 100 list, or the equivalent of Tranco list or the Crux list, all those things. Many of those top names are not signed. That's probably one of the biggest missing points. And zones, I don't think are at least signed by default for most registrars or providers. So there's still a lot missing, but there's certainly been some work that probably would have never happened if it wasn't for Dan Kaminsky, is the point of the slide. Now we can also compare the progress of DNSSEC to other systems that have gone through some transition or have tried to adopt or evolve. So the RPKI is probably the nearest one that we might compare. It's not a very good apples to apples comparison, but RPKI has been reasonably successful, maybe even in comparison to DNSSEC. The last statistic that I saw was that of all the IPv4 address space, that literally the 32-bit address space, 35% of it's covered by ROAs. That includes things that will probably never have a ROA, like the Class E reserve space. World Wide Web, I think it's probably pretty close to ubiquitous now that we have certificates for most everything that we care about. Although if you read some of the research papers, at least in the totality of all the websites that are out there that you can survey, the actual validity rate can actually be quite dismal in comparison. But it's still, I think we would argue that it's reasonably successful, and we're pretty happy with more or less how that's turned out, with some exceptions. Other systems may be less comparable. I won't spend much time on them. You can think about some of the lessons and how things compare to between each other in DNSSEC. So we began some work not too long ago looking at a problem that some in the community, at least those with an interest in DNSSEC or DNS encryption or validation and authentication worldviews had come, and often we're pointing at this page IANX, and I'll have a reference to it at the very end of the slide deck if you want to look at it. This is a very popular page that many people cite and reference and refer to, but it's a very subjective look. It documents a lot of either known or observed DNSSEC-related problems over the years. But it's a very self-selective list, and the person or people who run it have a clear point of view, and it's not in favor of DNSSEC. That's fine. I don't necessarily care about that, and we don't care about that necessarily from a research perspective, but we do care about, how truthful it is, how realistic it is of the real world. And so we sort of started from this, and we want to evaluate, is what's being conveyed here is the ultimate message that, maybe DNSSEC really isn't that great. Is that the case if we look at the data, if we look at the system itself? Does it look better, or does it look worse, or is this largely jive with what we're seeing in the wild? So we thought this is a good time for science. There's a system called SecSpider, which is a system that's been running for like 20 years. What it does, it actively polls, acting like resolvers, goes and looks at zones, looks at all the name servers, and does queries like a resolver would, and evaluating the status of DNSSEC-related responses. And so it's been collecting data for a long time, and so it's got a lot of data. So we can just look at this data. We can see how bad are things, or how good are things. So that's essentially what we're doing. So here's the research-related questions that when you approach it from, as I'm pursuing my PhD, as you approach a problem like this, this is the sort of place you sort of begin. What is it we're trying to do, and how do you do it, and what are we trying to provide as an answer? So one of the first questions is what is a DNSSEC-related outage? What do you consider DNSSEC-related outage? So we talk about that. How do we actually detect it? We're using SecSpider, just active polling mechanism. There could be other ways to try to go about approaching this problem. This is the way we're doing it. It's maybe not necessarily the only way or even the best way, but it's one way to do it. And ultimately, we're not finished yet, but ultimately, what can we say? Can we quantify the number of outages? Can we measure some sort of impact that we're seeing? Here's a short abbreviated definition that we came up with. Basically, if you were to perform a query and there was no DNSSEC involved, and it would have succeeded, then we say, well, there was probably a problem then with DNSSEC. Either a signature expired, or maybe something about the signing process made a system go kablooey, and if it weren't for that, maybe things would have been okay. When we defined what a DNSSEC outage is, we started building ourselves a classifier. When you look at the IANX list, sometimes it's not always clear what's happened, and sometimes it's not always correct. It's not a real rigorous examination of what's happening. But if one name server was providing bad answers and 3 of 4 other ones were okay, is that a DNSSEC outage or is that a degraded service? So, whatever you may call it, we classify it differently in cases like that. So currently, we're looking at this data, but we're right now focused on DNS key RSIG expirations. This is one small view of the world to look at the problem space. There's other ways you could classify an outage, and we're doing that, but this is the way we're kind of started. And it's a pretty good way because it catches a lot. It sees probably many of the common problems. If you look at the IANX webpage, a lot of the problems listed there have to do with scenarios like this. We create a decision tree, and then we classify. We look at it from the case of, is the whole zone out? Is it certain name servers that are responding with bad data and some are okay? From a perspective of our pollers, is one poller getting a different view of the world than another one because they're geographically, just getting different responses because of some sort of interception device or things like that. So here's an example of our flow tree. This isn't a complete picture, but this is, sort of how we started approaching the problem. Basically, so given a zone and an interval, do we have any expirations for this zone? If no, okay, well, there's no outage and we're done. If yes, then we start to evaluate. Is it all the name servers? Is it all the name servers that are just up, or is there some name servers that we couldn't reach? Maybe that's a full outage for DNSSEC, or maybe it's something different. Maybe there's some power outages happening too. We may not always know exactly how to diagnose the problem. So we have to be careful about, over prescribing what's happening here, but we can certainly describe what we see. So this is kind of an uninteresting graph, but I just wanted to show you what IANX.webpage lists for the outages. Now, IANX has 3 groups. It has a section for root, it has a section for TLDs, and it has a section for kind of a collection of other things. We focused on the TLDs for IANX for this talk, just because it's a little easier to wrap our heads around. I think we can all assume that TLDs are all important to some degree. So any problems in TLDs are a problem generally that we care about. Some of the other listings on the IANX webpage, there's zones we don't necessarily care about. There's only 2 listings for root, and they were over 10 years ago, so there's maybe not much to see there. This is showing basically the number of basically links to click on the TLD section of that page over the course of 15 years. There's 110 unique names. So some of the names have had recurring problems. And if you look at the most common ones that are listed, this is how they shape. Most of these you might not be that familiar with. You probably are familiar with at least one down the bottom, which is .gov. That one, I think we could all agree, is probably reasonably impactful. There was 3 events that were listed. Of course, there's no context for this graph because the Gov ones were, again, those were also about 10 years or older ago, so they occurred quite a long time ago. But you can see some of the zones have had recurring problems, some quite a lot, over at least the span that IANX was looking. So we wanted to see, do we see everything IANX sees? Or do we have data that can confirm what it sees and maybe see things that it doesn't see? And so we took one of the TLDs that it saw a number of events for, and we sort of just lined it up. And we actually are able to see in the SecSpider data everything that IANX reported, plus some other things that it didn't report, except for one event, that one in 2014 in July. I think it was a very short-lived outage. It was maybe like a couple of hours. Because of the SecSpider polling interval, we just didn't see it. It just occurred within outside of a window, then our pollers would have caught it. So this isn't necessarily accurate for all the things that IANX reports, but this seemed to be a good, reasonable sample that we do see a lot of what IANX is reporting, so I think we'll be able to see something useful here. So SecSpider polls roughly about once per hour for everything that it needs to poll, which includes all the name servers for all the zones that it's monitoring. It does this about once a day. We've talked about maybe doing it more frequently. And you'll see some graphs here in a minute about whether this is reasonable or not. But we think this is probably good enough to make, again, something to say about that sphere of the cow. Again, kind of an uninteresting graph here, but this is what SecSpider sees for what we call events, not necessarily an outage here, but when we see DNS key RSIG expirations over the course of just a few months, we see a lot of events. We see a lot of expiration events, like 250,000 over over about 6,000 names. Now, many of these are long-lived events. These names or zones have been out for a long time. They may be not so impactful, but we don't see, what's interesting is we don't really see any real peaks or valleys here. There seems to be a steady state anyways. So if there's anything interesting about this graph, it may be that. And from that graph, from that data, we took a look to see, for this period of about 4 months, in the CRUX list, which is basically this Chrome user experience list that's data collected by the browser, can we match up to see outages that appear in that list? This is to give us an idea of how impactful that the outages we see may be experiencing. And there's quite a few gov names in here, not .gov, but some of the subdomains under that. And there's some international names. Some of this is not too surprising. Now, these aren't necessarily complete outages. These are just, there was some event that happened with these names. So I'd have to go look at the data, and I can't tell you off the top of my head if like jplnasa.gov was out for that interval of 60 plus what we call buckets. And a bucket is kind of a rough interval that might be up to an hour. So it could have been up to 60 hours, either contiguous or discontiguous. But it may have only been for one name server, or may only been for a certain kind of scenario. So we kind of followed that thread a little bit, looking at the impact based on things like the CRUX list, and we also use the public suffix list, kind of looking to see where things lay in this 4 months of data. We did find some matches, 17 out of 1 million. That doesn't sound like very many to me, but also recall that there's a lot of those popular names that aren't signed. So, it's 1 million sounds like a lot of names, but a lot of those are not signed. So what the percentage is, may be something less, of course. We then took a look at the parent and the TLDs in our list of data to see if they match anything in the CRUX list. And there were some. Doesn't seem like an exorbitant amount, but there were certainly some. And the public suffix list just coincidentally matched 17 exactly as well, and they were almost all, except for one, internationalized domain names. This one was kind of interesting, I thought. So we estimated what the outage duration time was from our data over this period of time. This is a very rough estimate. We basically rounded to a day. So this first bar is at the highest peak here on your left. Make note that the y-axis is a logarithm. So it's actually quite a bit higher than all the other ones. So it's nearly 1,000. So most of the outages that we can measure appear to be for about under a day. Most of them are usually just an hour or two. And then there's this long tail. When we started looking at the data, and I just showed you, for example, the very last outlier one was this bad DNSSEC test DE name. Well, this is a record that's intended to be expired. So the impact of this is really nil. We don't really care about it. There's a few of those kind of names. Not most, but a fair amount of those kind of names exist to the right. They just have been out for a long time. Well, they're intended to be out. There are a lot of people doing research and measurements and test resolver sites and so forth that exist. But certainly there's some others that have very long durations. What are those names? A lot of them are not so impactful, especially if they've been out that long. You would probably guess they can't be that impactful if no one's bothering to fix them. But there's actually not that many of them. I mean, they're under 10 each in many cases here. But it's certainly not zero. But the median is quite small, I think, overall. Now, small is relative. We measure in days. The median is 2, and the third quartile is 3. That would be a long outage for most of us, but in the grand scheme of all the data that we see, maybe that's not so much. So here's an example of what we saw, which we would consider not a full outage. This do not call.gov name, we just happen to be polling it maybe at the right time of day. We had 4 name servers that responded right around the same time that we asked, and one of them gave us an expired result. And it's unclear why this happened. We suspect it's something like it just didn't get synced properly from the primary, maybe the hidden master or wherever the data came from, and the others were fine. So there's maybe some local knowledge that we don't have that will explain this. But it was interesting that we do see some of this in practice. And the gov zones in particular are kind of interesting because they re-sign very frequently, like less than 24 hours. I think that's pretty much for all of them. So it maybe stands to reason that you would see sort of disturbances in the force in gov names, and maybe more so where other zones where the key signings are for a much longer period of time. So we're not done. We still have a ton of work to do, but we're starting to come to some conclusions that we can make some sort of broad brushstrokes statements about. One is we see lots of stuff. We see lots of interesting events, certainly a lot of outage-related events. When we classify the outages, we're able to really focus in on sort of the impact, which I think is the really key part of us being able to say something useful about this. Like, what is the true impact if something is out? And not only the impact, but compared to other sorts of impacts. You know, we've all heard about subsea cable cuts, RPKI-related outages, or BGP hijacks and things like that. Is there anything so unusual about the outages that we see that we wouldn't see in other systems that are having other sorts of troubles that have extended outages? I don't know, maybe they're kind of comparable. Maybe that's the normal state of things as we have outages. And the overall quantity of events that we see is relatively small. We're monitoring now about 5 million names, probably a lot more than that. And we can count over that period of 4 months, and most of them are fine most of the time. You know, that 0.02%, maybe that is just the normal state of things. That doesn't sound too bad, you know, a 3 nines kind of classification for the whole internet. So I don't know, that's kind of where we're more or less at. Here's kind of what we're doing. Going forward, we're looking at the trends to be able to say things about, you know, what's the mean time to failure and to recovery when these things happen? Can we produce some sort of overall report for zones? We obviously are very interested in other DNSSEC-related outages, so we're not just this DNS key or SIG expiration we're looking at. I'm particularly interested in, after this, maybe thinking about ways that could reduce the fragility of DNSSEC. Can you change the system or the behavior of things so that it wouldn't be so rigid and that we can route around these errors a little bit better? So ultimately, where we'll hopefully we will end up, because it's important for me for my PhD, is there'll be some publication that has all the rigorous results and data and measurements and plots and graphs and everything. That'll get published somewhere, and then we can say we're done and we'll move on to the next thing. But that's kind of where we're headed with all this work. So I think that's pretty much all I have. If anyone has any questions or comments, it looks like we have 7 or so minutes. And I knew Warren was gonna come.
You knew that this was coming.
I've expected this. I don't. Maybe you have some new stuff, but I know we've talked about this before. So go ahead,
Can you
Warren.
go back to the sort of histogram type graph? That one, yeah, 19, I guess it was.
Yep.
So you sort of went past this thing and said most outages are only for a short while, like a couple of hours or so. And you also said 0.2% of things being broken. That sounds okay to me. Those statements don't really seem to make a huge amount of sense to me. Like 0.2% of names being broken, meh, to me feels like a much bigger issue, especially if you're one of the 0.2% of people. But
I don't know if that's a question or a statement, but I mean, I'll.
Don't you think? They were going to turn it into a question. I mean, to me, I guess we're taking away very different things from this. To me, these results look scary and as though this is very fragile and it's an additional source of breakage. So I don't quite know how it is we have this different set of views on, is this an okay amount of breakage for a system to have? So I guess, yeah, maybe it was a statement, so I guess I should stop talking and go sit down.
Maybe I'll respond this way. It's not necessarily an answer to your question, but maybe we do have different views, but maybe not so much. You know, I probably shouldn't be drawing too many conclusions just yet. Let me put it that way. So it's a little early to really say that we're still kind of refining our results here. So this is a very rough look. So some of this may be not exactly precise or even correct in some parts. So I'll sort of defer a real answer maybe until we finish all this work.
Just to clarify, when you say broken, does that mean that they were working and then they went broken, or they were broken for a very long time and nobody bothered to fix them?
So in this case here, so this is describing full outages. So this is when the entire zone is out in this picture. That 0.2% was like anything could be wrong. So this would be, like if you're doing validation, you can't access the zone. Is that,
Were they up and then
I can't tell you if they were I don't know off the top of my head if, I haven't done the measurements to say. They gave us an answer and it was just, it would have been valid if you weren't valid. It would have been an answer that would have worked if you weren't validating. That's probably true, but I haven't tested any of that. It's actually hard to test that, especially the historic data. But go ahead, Jeff, sorry.
Jeff Houston, APNIC. Look, there's kind of two problem spaces with DNSSEC and the DNS. The first is that when you put in timed data into the DNS, like expiry dates, you get this kind of longevity problem where the data exceeds its given time, it's invalid, it's down for everyone, and that's fine, and that's easily found and easily reported on. The other part of stressing out DNS is that the signatures add size, and in particular for negative answers, where you stuff in more and more information, and then you get into this entire problem of, that's a really big answer. Some folk don't like that in UDP. They set the truncation bit. They say, go to TCP. The resolver goes, well, I don't like TCP. And so you get this sort of secondary class of problems that it's not down for everyone, just me and my recursive, my stub resolver. It's kind of depends on you as much as the primary source of data. And that's, I think, part of the big unknown with DNSSEC, trying to quantify that kind of problem where some parts of the DNS don't work well with DNSSEC, and only some users get to experience the hell that results from that. And that gets really difficult to quantify when you're talking about the fragility of DNSSEC, but nevertheless, it's there, and it's a consistent problem. And that's, I think, the challenge in what you're trying to do, is to put some quantification as to, well, how fragile is it? And it's kind of, well, how good are the resolvers out there is really what you're looking at. And I haven't even got into multiple providers with online signing trying to synchronize across multiple key sets, which these days seem to demand its own set of PhDs to make work. Thanks.
Thanks, Jeff.
Hi, Tail, Salesforce, but not talking for anybody. So first off, I want to say I really am sympathetic to the argument that people can come to the rational conclusion that maybe DNSSEC is not worth deploying when it will make some things fail that otherwise would have harmlessly worked. Nonetheless, as a DNSSEC advocate, I would say that the risks are worth it, but I definitely appreciate the effort to try to mitigate these places where it should be softened. The reason I got up, though, was I was a little surprised when I saw on your second or third slide where it said 80% of DNS data was inconsistent. In fact, I had somebody message me when they saw that line and said, wait, what?
This is, actually, I'll fast forward to, there was a paper I can point you to.
I, in fact, found the paper.
Okay. So I hope I cited it more reasonably
I
accurately.
don't think that actually, and you might be able to clarify how you meant the line, but based on what I saw, that seems to be exactly the inverse of what the paper was claiming. Right.
Maybe I made a mistake there.
And it was specifically not about all DNS names, but specifically about delegations, right? Matching parent side and child side of the delegations. So that is an alarming number, and there are legitimate problems. Like, I'm not trying to take away from any of the other problems you're describing, but that scary number is not an accurate scary number.
Okay, thank you for correcting that. Thank you. Yeah, it did sound high to me at the time, so now it makes sense. Thank you for finding that. Yes, sir.
I'm wondering, did you look at or consider tracking the behavior of public resolvers versus what you were seeing with your probes?
No, we're just looking at the SecSpider collected data, which their active pollers, I guess, behave kind of like a resolver, essentially, more or less. That would be, like I said, another way to view the world, but yeah, we haven't looked at that. And I'm not sure how we would have to pull the public resolvers, I'm assuming. Is that what you're suggesting?
Yeah. In some cases, they may respond differently than you would expect.
Yep.
And would you have tracked or cared about a zone that went insecure and then secure again?
I think I missed the first part of your.
Would you have cared about or tracked a zone that went insecure and then resecured itself?
Yeah, we've talked about that because we've talked about a few things like that to see if especially after an event where maybe something expires or some outage event. Does the zone then just go insecure ultimately? Do they start taking, OTS records and things like that? Or does it come back and get, what is there big gaps in intervals and things like that? So I can't tell you much about what we can see there, but that's something we've considered looking at, yes. Okay, do we have time for one more?
All right.
Thanks, Krasi. I really like this work, and one thing that I have always been wondering about is why do these events occur? And just recently, .fi said that they were doing an algorithm change, right? And I believe they told their customers it was like, 2, 3, 4 weeks of an outage. And so I always wonder, are these outages something that were planned for but not notified? Yeah, you're shaking your head, Warren. I don't know. Right, I'm just saying I wonder about these items because getting to the root cause is important because either we do key management correctly, right, and a lot of technologies use this, or we just give up. And I mean, it's not just for DNSSEC, but for all other different protocols.
Yeah, from a network operations background, I've felt the same way. I've had to be very careful to go into the diagnosis and phase of this work because we won't be able to necessarily know. But we may be able to get some hints like we've seen in some of our data where there does seem to be patterns for some zones that it's coming due to a record or zone to be re-signed and it's not, but not long after it's signed again. So implies there's a manual process there happening for some zones. And that's fixable, I guess, by maybe automation or something. But yeah, we won't probably be able to actually answer that though.